Hi, hello everyone. Welcome to CCNA Enterprise 200-301, Part 1 CCNA Routing Introduction. My name is Mani Popal, double CCI lead instructor at system.ca. So guys, in this lecture, we are going to talk about introduction to basic routing. When you look at this particular diagram, we are going to see four routers. There's a router 1, router 2, router 3, router 4. And also routers are connected to different network segment. So in this example, router 2 is connected to 10.10.10.0 network segment, and router 2 also connected to 10.11.11.0 network segment. And also let's assume this LAN is 10.15.15.0, this local area network. And let's assume this LAN is 10.25.25.25.0/24 network. Okay, so subnet mask is /24. So if you want to make two LANs to talk to each other, what they do is they do WAN. WAN stands for wide area networking and LAN stands for local area networking. So if you want to make routers to talk to each other, the languages of a router is called routing protocols. In CCNA, you are going to heavily study what is static routing, what is OSPF routing, what is EIGRP routing. BGP will be coming in CCNP or high level studies because BGP is called routing protocols of internet. Again guys, OSPF stand for open shortest path first. EIGRP stand for enhanced interior gateway routing protocol, and BGP stand for border gateway protocol. So in this journey, we are going to learn more about the routing part of CCNA. And router is a layer 3 device. So remember, switch is a layer 2 device. Switch understand MAC address. On the other hand, routers understand IP addressing. So router is a layer 3 device. Basically what it's doing is moving packet from one location to other. Technically it's moving frame, but router only understand packet. As I told you, router connects to multiple network segments together. So if you want to connect 10.10.10 to 10.11.11, only way you can connect different network is by using a router. Routers, they run routing protocols. The main advantage of routing protocol is the languages of a router. It builds the routing table. Routing table has best path to destination network. Again, you have to look at the routing table. On a Cisco router, this command will show you the routing table. So the command is show IP route. As I told you before, routing protocols are languages or communication mediums of router. They exchange information and they build the routing table. So some of the dynamic routing protocols are RIP, OSPF, EIGRP, BGP, ISIS. So RIP stand for Routing Information Protocol, OSPF stand for Open Shortest Path First, EIGRP stand for Enhanced Interior Gateway Routing Protocol, BGP stand for Border Gateway Protocol, ISIS stand for Intermediate System to Intermediate System Routing Protocol. So what they are saying, EIGRP, OSPF, RIP, they are called as Enterprise Routing Protocol. That means big companies, they use this protocol. And BGP and ISIS, they are called ISPs Routing Protocol. That means Bell, Rogers, Telus, Verizon, Sprint, AT&T, they are using BGP and ISIS inside. And router don't understand MAC address. Router look at the packet and look at the destination IP address in the routing table to figure out where to send the packet. So guys, again, this is a very important slide. Please go through a couple of times to understand the basics. Now we are going to see OSI reference with the routing. But before that, let's draw high level entire OSI model. So remember, there is a data. OSI model has data. Data is at layer 7, layer 6 and layer 5, and data is encapsulated inside a segment. So segment is at layer 4. Okay, so this is called data to segment at layer 4. Okay, so again, this is called application layer, presentation layer, session layer. This is called transport layer. Now segment is encapsulated inside a packet. Okay, so segment is encapsulated inside a packet. Packet is at layer 3 and it is called network layer. Packet is called network layer. Now packet is surrounded or encapsulated inside a frame. Packet is encapsulated inside a frame. frame is layer 2. Frame is layer 2. We are calling as data link layer. Data link layer. Finally, the frame is the one which is going on the wire. Okay, frame is going on the wire as bits. It's broken to bits and byte is going on the wire. So data to segment, segment to packet, packet to frame, frame to bits is happening on the layer 1. So frame is going on the wire, but the router only understands the packet. So router will break the frame and look into the packet. If you are looking into the LAN environment switch, it look at the frame, because IP address is on the packet and the MAC address is on the frame. So again guys, this will give you, so it's a different part of CCNA. They are talking about OSI model and TCP IP model. Let's look into the lecture. Router looks at layer 3 IP address. Switch looks at the layer 2 MAC address. Packet is inside the frame. That's right, packet is inside the frame because packet is encapsulated inside the frame. Router breaks the frame and check the packet in the routing table. Normally packet does not change from source to destination. Very important concept. Unless you do some kind of a NATing, packet is always same. That means source IP and destination IP remain the same. But on every link, what is changing is frame is changing. Guys, I think as you study, things will be more clear. Let's go to the next slide. Okay, so now what are the ways you can differentiate the routing protocol? Routing protocol can be classified into two different ways. First method is called link state versus distant vector. I always tell link state is a good routing protocol. On the other hand, distant vector is a okay routing protocol. So that means good is better than okay. Okay, why link state is good? Routers, they establish something called neighbor relationship by using hello packet. That means these routers keep on saying hello. For example, OSPF on an Ethernet segment, it sends hello every 10 seconds. And routers, they do not advertise update, but they advertise something called link state update. So it's called link state advertisements, not the routing updates. So through the link state advertisement, they try to build something called link state table. Sometimes it's called link state database. Sometimes it's called topology table. And again, link state routing protocols are good because they are doing multicasted. And those routing protocols, they build three tables. One is called neighbor table, other one is called topology table, other one is called routing table. Topology table is like a Canada map, entire Canada map. Routing table is nothing but Toronto router, Calgary router, Montreal router. So every city will calculate its own routing table. So again, very good interview question. What are the two best protocol or good protocol? OSPF and ISIS, because they are link state. Now why they are okay protocol, why they are not good protocol? Because there is no hello packet and there is no neighbor relationship. Updates are broadcasted. So unlike here multicasted, here broadcasted, and it has only one table called routing table. And the OK protocols are RIP and EIGRP. EIGRP is special because it is a kind of a combined protocol. It's called hybrid protocol. BGP is totally different game. It is called path vector protocol. So in CCNP, you'll be studying EIGRP and BGP more. Okay guys, so you have to know this classification. Let's go to the next slide and look into the other type of classification. So finally the classification called, this is a method 2, is called classless and classful routing protocol. Again, classless is a good protocol and classful is a okay protocol. Whenever possible, you have to always go with good protocol. So the reason is a good because it supports something called VLSM. VLSM stands for variable length subnet masking. That means it supports any subnet mask. That means /8, /11, /16, /18, /19, /24, /27, /30, any subnet mask. These are all good protocols. OSPF, ISIS, RIP version 2, EIGRP, BGP, ISIS. The reason this is called classful protocol is OK protocol because they only advertise classful subnet or they only support classful subnet. That means /8 for class A, /16 for class B and /24 for class C. They only advertise default classes, so they do not support VLSM. The OK protocols are RIP version and EIGRP. So guys, let's look into different video to gain more knowledge. Talk to you guys later. Hi, hello everyone. Welcome to CCNA Enterprise 200-301, Part 2, CCNA Routing Table and Part Selection. My name is Mani Poopal, double CCI lead instructor at CCNA.ca. In this lecture, we are going to look at routing table. If you want to see the routing table on a Cisco router, you type the command show IP route and you'll be getting an output like this. O stands for what routing protocol you are learning. In this example, O means OSPF routing protocol 100.1.0/24. So first 100.1.1.0 is called destination network and /24 means destination mask. Then in the square bracket you can see 110 and 65. First 110 is called administrative distance. So this stands for administrative distance. Second one is called metric. So the first number is admin distance, second number is metric. Then 1.1.1.100, this is nothing but your next hop address. That means it is not your local IP address, your neighbor's IP address. Okay, so next hop means neighbor's IP address, and also you are going to see your local interface. So local interface is called FA00. You can see this one. So it doesn't matter how the routes are learning. Maybe it can be learned from OSPF, EIGRP, whatever routing protocol. You should understand and try to figure out how to read the routing table. Please take a moment to understand more about the routing table. Okay, what is administrative distance? We talked about administrative distance and metric before. In the routing table, in the square bracket, if you see x/y, the first number represents the administrative distance and the second number represents the metric. The administrative distance, basically, it tells how trustable is the routing protocol. Okay, so administrative distance defines the trustworthiness of the route. There is a range for administrative distance 0 to 255. So lowest is 0, highest is 255. And also remember, lowest administrative distance is preferred. And routers select the route with the lowest administrative distance as the best route. Suppose if two routers have the same administrative distance, that means they are learning from same OSPF protocol, then router chooses to next number, that's called metric. The lowest metric is preferred. So remember, lowest administrative distance is always preferred. If the administrative distance is same, then it's going to go to the next criteria is called lowest metric. So take a moment to read about the different route types, routing table symbol and administrative distance. You can see in this particular chart, connector route is called C, the symbol is C, admin distance is 0. The static route is S, the admin distance is 1. EIGRP summary route is D, admin distance is 5. EBGP, so that means external BGP symbol is B, admin distance is 20. EIGRP internal is D, admin distance is 90. OSPF has couple of route types. Again, this will be covered in CCNP. Admin distance is 110. ISIS is I, admin distance is 115. RIP is R, admin distance is 120. EIGRP external is DEX 170. IBGP is 200. BAT routes are 255. So this list is coming from lower to higher, and make a note, EIGRP symbol is D. EIGRP symbol is D. Again, sometime it could be tested because OSPF is O, then RIP is R, but the EIGRP alone is D. But you have to make sure study this one. So it's best to study lowest to highest. It will help you in your CCNA journey as well as in your CCNP or CCI journey as well. Okay, so it's very important concept, guys. Try to understand administrative distance. Next, we are going to go and learn about metric. And in the routing table, the second after slash, the second number represent metric. Metric define path to a route. Different routing protocol have different metric. If admin distance is same, then router look at the metric. If admin distance is same and the metric is same, then the router do something called equal course path load balancing. That means router will send packet through one path, second path, third path, etc. If the admin distance is same, but if the metric is different, if you want to do load balancing, Cisco's protocols can support the load balancing. There's a feature you'll be studying in the advanced routing courses. It's called unequal course path load balancing. I want to give you examples of metric. For RIP, the metric is called hop count. Hop count means how many routers it has to pass. For OSPF, metric is called cost. Okay, so these are the important things. For EIGRP, there are 5 different metric value. One is called bandwidth, delay, other one is called load, then reliability and MTU. Reliability and MTU. So remember, just to understand what's the metric of OSPF, it is cost, it is based on bandwidth, is an inverse bandwidth. For EIGRP, even though there are 5 different metric value, by default it uses bandwidth and delay. We will talk all these one when we talked about OSPF and EIGRP separately, but you must understand how to read the routing table and what's the difference between admin distance and metric. You can see all those ones I'm repeating here: RIP, EIGRP, OSPF, ISIS, BGP. What are the different metrics? So just try to know this one. And BGP is special. BGP has different metric. One is called AS path, next hop, origin, med, local preference. They are called path attributes. Okay, so let's go to this slide, next slide, because we already went through this one. Okay, this is very important, guys. Okay, so how routers do the path selection? We always said router looks at the lowest admin distance. That's not the true one. Okay, router look at the routing table and pick a prefix, that means subnet with the highest mask. That means if you want to go to 10.10.10.9, both 10.10.10.8/30 and both 10.10.10.0/24 is valid. So it doesn't matter what protocol is learning, it's going to always choose 8/30 than 0/24 because highest prefix. Okay, so remember, always highest prefix wins regardless of routing protocol. Then if the prefix is same, then only is going to go to the lowest admin distance. Okay, so the first is highest prefix, then lowest administrative distance. Suppose if the administrative distance is same, then it's going to go to lowest metric. Then if the metric is same, then as I told you before, routers will do load balancing up to 4 different paths. It's called equal course path load balancing. But if the admin distance is same, if the metric is not the same, still load balancing is possible with Cisco's protocol. It is by EIGRP and IGRP. It is called unequal course path load balancing. So guys, for CCNA exam, you must know the route selection algorithm, and again the order is very important. I will repeat one more time: highest prefix mask wins. If it is same, lowest admin distance. If it is same, lowest metric. If it is same, it is going to do equal course path load balancing. Hi, hello everyone. Welcome to CCNA Enterprise 200-301 Part 3 CCNA Routing Static Routing. My name is Mani Popal, double CCIE lead instructor at system.ca. So in this lecture, we are going to see static route. So static routes are manually configured by the administrator. If any link fails, they have to manually remove the link and add the manually remove the static route and add the new static route. There is more administrative overhead in static route. There is less routing protocol overhead. Static routes are only good for if you have 2 or 3 or 4 routers, minimum number of routers. The main difference between static route and dynamic routing protocol: in static route, you will tell the local router how to go to other networks, and also in static route, you will not advertise about yourself. That means you will not advertise about your connector route. It's the exact reverse for your dynamic routing protocols. And we are going to see a special how to configure static route in the next slide. To configure static route, there are 2 different ways. First command is IP route. destination network, destination subnet mask, destination network, destination subnet mask. Then you can put a next hop IP address. So this IP is called next hop. Next hop means not your IP address, your neighbor's IP address. Or method 2 is you can type IP route, destination network, destination mask. Then you put your own IP, own interface name, own interface. This become your next hop. Most of the time, industry prefers the method 1, next hop address. But here administrative distance is 1. In this case, administrative distance becomes 0. So static route has two administrative distance. One is 0, other one is 1. It all depends on how you define the static routing. Again guys, it's a manual overhead. We are going to a lab very soon. Okay. There's a special static route. Our next slide will talk about the special static route. The special static route is called default static route. Sometimes this is also called gateway of last resort. Sometimes you learn the default route by using dynamic routing protocol, or you can manually configure default static route. In the default static route, both destination network and destination mask become 0. And these are the examples of default route. One is IP route 00000000. Then you put the next hop 1.1.1.100, or you can type IP route 00000000 FA00. Same as above, administrative distance is 1 here, administrative distance is 0 here. So now remember, if you have static route and if you are having a dynamic routing protocol, always static routes are preferred by the router because of the lowest admin distance. So now we are going to, in the next slide, we are going to talk about something special. It is called floating static route. So what is floating static route? Always static routes are preferred by routers due to low administrative distance than dynamic